Is there anything in sports more electrifying than a slam dunk? It's just this incredible mix of pure power and artistry. But you know what? Behind that jaw-dropping moment is some seriously fascinating science. So let's break it down.
I mean, really, how does a human being launch themselves high enough to slam a basketball through a hoop that's 10 feet in the air? It looks like magic, something only superheroes can do. But what if I told you the secret isn't locked away in some advanced sports lab? What if the answer is hiding somewhere a lot more familiar?
Yep, you heard that right. For this explainer, we're going to unpack one of the most explosive moves in sports using the exact same principles you'd find in a basic middle school science book. And it's actually the perfect way to see how fundamental science can explain some truly extraordinary things.
Okay, so let's think about this like a problem we need to solve. To get off the ground, you have to generate a huge amount of upward force, and you have to do it in a fraction of a second. To pull that off, your body needs two key things working together perfectly. You need an engine to create the power, and you need a framework for that engine to push against.
So first things first, the engine. All that raw, explosive power comes from our muscular system. This is the biological machinery that converts energy into the movement we need for a massive jump.
And the key to the whole muscular system is one simple but powerful word: contract. Like the textbook says, muscles are the only part of our body that can do this. This one-of-a-kind ability to shorten with force. Well, that's the foundation for every single movement you make, from a simple blink to an earth-shattering dunk.
So, our bodies have three different kinds of muscle. Cardiac muscle, that's your heart, and smooth muscle, that's the stuff in your digestive system. They're both involuntary. They just work automatically without you even thinking about it. But for a dunk, you have to be in the driver's seat. You need intentional, explosive power. And that's why we're going to focus on skeletal muscles.
And this is absolutely crucial. Skeletal muscles are voluntary. You are in conscious control. You decide I'm going to jump, and your brain zaps a signal to those muscles, telling them to fire. Without that conscious control, there's no dunk. It's as simple as that.
And here's how they do it, which is just brilliant. Muscles can only pull, they can't push, so they have to work in pairs. To get ready for a jump, you crouch down, right? That's your flexor muscles pulling and bending your joints, storing up energy just like a coiled spring. Then, to explode upwards, your extensor muscles contract, powerfully straightening your joints and releasing all that stored up energy in one go.
Okay, so we've got our engine, but an engine by itself doesn't really go anywhere, does it? It needs a chassis, a frame, and that's where our skeletal system comes in. It's a strong, supportive framework that our muscles need to act upon. Now, our skeleton is split into two main parts. The axial skeleton, that's your core, your skull and ribs. It's all about stability and protecting your important organs. But the appendicular skeleton, that's your arms and your legs, well, that's where the action is. This is the part that gives us the mobility to make those big athletic movements.
Which kind of brings up a good question, right? Bones are hard, they're rigid. So how in the world do we get the flexibility to crouch down and spring back up? How does this rigid frame allow for such fluid motion? Well, the answer is joints. Joints are just this brilliant bit of biological engineering. Think of it like this. Ligaments are the tough, flexible straps that hold the bones together, while cartilage is the super smooth cushion on the ends of the bones that keeps them from grinding against each other. Without joints, we'd be as stiff as a board. And for a huge jump, you gotta bring out the big guns of your appendicular skeleton. Your pelvis acts as a solid base. The femur, your thigh bone, is this massive, powerful lever. And the tibia and fibula in your lower leg, they're what transfer all that force into the ground. These aren't just bones, they're the tools your muscles use to launch you.
Okay, so we have our engine, the muscles, and we have our framework, the skeleton. Now it's time for the fun part. Let's put it all together and watch how this amazing machine creates a slam dunk.
It's basically a three-stage rocket launch. Phase 1, crouch and load. Your flexor muscles contract, you get low, and you're storing up a ton of potential energy. Phase 2, explode and extend. Your extensor muscles fire like crazy, straightening everything out and converting all that potential energy into pure upward motion. And finally, phase 3, liftoff. That force slams into the ground and the ground pushes right back, sending you soaring.
This simple sentence from our textbook just says it all. It's the perfect summary of this incredible partnership. Every single jump, every step, every movement you make comes down to this one simple truth. Muscles pull on bones. That's the magic behind the entire machine.
So why did we do all this? Why break down a slam dunk using a science textbook? Because when you understand this one incredible action, You get a little window into how our bodies do, well, everything.
The key word here is synergy. This perfect teamwork between your muscles and bones isn't just for pro athletes. The same exact principles that launch a basketball player sky high are the ones you use to get out of a chair or reach for something on a high shelf. A slam dunk is just that beautiful system being pushed to its absolute limit.
Seeing how these systems work together really shows you that your body is an amazing machine, capable of incredible things. The science is surprisingly simple, but the results, they can be spectacular. So it really just leaves you with one thought. Knowing what you're capable of, what are you going to challenge your body to do next?